Hi everyone and welcome to Electrical Know-How. Today we're going to be taking a bit of a look at Ohm's Law. So let's start off with who is Ohm. So George Ohm was a German physicist and is best known for his work which outlines the relationship between voltage, current and resistance. So his work has gone on to be known as Ohm's Law, and it's arguably the cornerstone of modern electrical science. So everyone knows Ohm's Law. If you do anything electrical, you know Ohm's Law, and it is inside of every single electrical circuit. So it's arguably the most important thing that you will learn in all of electrical theory. So what is Ohm's Law? Ohm's Law says that inside of an electrical circuit, the current is proportionate to the voltage and disproportionate to resistance. So in layman's terms, it tells us that the current, voltage and resistance are mathematically linked. So I can't just double one of them without having some impact on the others. And we'll have a bit of a look at those links a little bit later. But for now, let's talk about what is an ohm. Right, so an ohm is an electrical measure, but in electrical science, it's common that terms are named after the people who helped to identify or define them. So that includes terms like farads after Michael Faraday, or watts after James Watts, amps, volts, and there's plenty more electrical terms that are named after people. The same is true for an ohm. So this is a measure of resistance. An ohm is a measure of resistance, and it's named after George Ohm. The symbol for an ohm is this one that you can see just down the bottom here, which is the omega symbol. And you'll see that one pretty commonly around the place. So Ohm's Law is a formula. So represented here we have V is equal to I times R. And so V being volts, I being current, and R being resistance. It's up to you how you want to remember Ohm's Law. For me personally, I remember it as V equals IR, but I do know other people out there that remember it as I equals V over R, or it's up to you. It's your own personal preference as to how you remember it. But the three variants are that you've got V equals I times R, I equals V over R, and R equals V over I. Also, if you're that way inclined, you can also go for the magic triangle. So V, I, and R. All you need to do is cover up the one that you're looking for. So in this case, let's say we are looking for R. We just cover up the R, and it tells us straight away that the formula we would use is V over I. The same if we were looking for I, it would tell us that the formula that we're looking for is V over R. And lastly, if we were looking for the volts, we cover up the V, and we can see that I times R will equal the volts. So it's up to you. Some people like magic triangles, some people don't. It's just a personal preference, and I'll leave that up to you to decide. So let's have a little bit of a look at Ohm's Law in action. So we've got a current here, and we can see that we've got a supply voltage of 100 volts. We've got a supply current of 4 amps. And we've got lamp resistance. We've got a little lamp in here, and it's got a resistance of 25 ohms. Right, so if we apply our mathematical formulas, we can see V equals I times R. So we've got 100 volts is what the voltage is, and that is equal to the 4 amps multiplied by the 25. So we can see that Ohm's Law in this case is true, and this circuit is correct. Similarly, we've got I 4 amps is equal to 100 divided by 25, the volts divided by the resistance. Alright, so again we can see that it's a true statement, and the same for R. We can see that we've got 25 ohms of resistance, and that is equal to our 100 volts divided by our 4 amps. Alright, so let's have a bit of a look. We can use Ohm's Law, and why it is useful is because we can use it to find missing values. So we can see here that we have 100 volts as our supply voltage, and our lamp resistance is 25 ohms. And we don't know our supply current. We don't know the I in this case. So we use our formula, and over on the right here we can see that we use I equals V over R. Alright, and so we're going to say that our 100 volts is going to go on top, that's our V, and our R for resistance is going to come across and go on the bottom. So 100 divided by 25 means that our amps is 4 amps. So we know that's true because this was our previous example, but that is how we would use Ohm's law to find missing values. We'll just try it one more time just to make sure that we've got the hang of it. So in this case here, we've got our supply current of 4 amps, we've got our resistance of 25 ohms, and what we're trying to find is the supply voltage over here. So we're going to take our V equals IR, and all we're going to do is say I, which is 4 amps, multiplied by R is going to give us our voltage. So 4 times 25, our voltage equals 100 volts. And again, we know that's true because we've done this now a few times, and that's always been our example. So Ohm's law, really, really important stuff. It can be used in every single circuit inside of any sort of electrical background, but every single circuit will comply or conform with Ohm's law. There's no exceptions to the rule. So that makes it really handy and something that as an electrician or an electrical engineer, something that's really, really important to your learning. So that brings us to the end of the Ohm's law video. Hope you enjoyed it and hope we were able to help you out.